All right, Math Leads 3.5, solving polynomial inequalities. So when you're setting up these inequalities, we want to make sure we shove everything over to one side and get it 0 on the other side. So number one here, we're already set up like that. So we're going to go ahead and define this function over here. And we want to find our zeros. So from this, finding our zeros, we're going to factor. We get x minus 3, x plus 1. So I have zeros at x equals 3 and x equals -1. So at this point, I want to set up an interval. And because I just really want to know what is happening in between these intervals, whether they're greater than or less than. It doesn't have to be exact values, but we want to know when these values are, because we are doing this algebraically. We're not necessarily looking at this graph on the right. So if I have, start with my smallest zero, so -1 and 3. So on these intervals, I'm just going to pick any point that falls in that interval. So -1 to -infinity, I'm just going to say, let's do f of -5. So as I plug that into my function, I get -8 times -4. And I don't really care that this is 32. What I really care about is that this is positive. So on my graph, I can see that things on this interval from -5, from -1 and over, we have a positive value. And again, now I'm concerned with this interval in the middle, which is from -1 to 3. So my favorite value in there is 0. So I'm just going to try 0 in there. So f of 0, and I get -3 and a +1. Again, it is -3, but what I really care about is that it's negative. So at that point, it's going to be less than 0. All right, and then now for my third interval, things greater than 3, I'm just going to pick 10. So f of 10 is equal to 7 times 11. Again, that's 77, but all I care about is that this is positive. Okay? So then I go back to my original inequality, and I know that, well, I define this as f of x. When is this less than 0? And I can look at my interval. Well, that's when things are negative. So when it's less than 0 was just only in this other interval. It was positive here and positive here, but it was negative in that interval. So my solution, and I want to give it an interval notation, it's non-inclusive. I don't have an equal sign. So that means that from -1 to 3 is my solution for that inequality. All right, let's look at example 2. So step 1 with these, again, is 0 to one side. So I'm going to subtract 3 from both sides. So I get x cubed minus 4x is greater than or equal to 0. I'm going to let this be equal to f of x, my function here. And then I want to find my zeros. Well, I can factor out an x, and I get x squared minus 4. That's difference of squares, so I get x times x minus 2 times x plus 2. So my zeros are at when x equals 0, 2, and -2. I'm going to go ahead and set up my interval with those 3 points. I'm at -2, 0, and 2. So I'll go ahead and select points. So let's do f of -5. So using my factored form, I get -5 times -7 times 3. And I really don't care what this value is, but I know that a negative times a negative times a positive is going to be positive. So I am positive on that interval. So, well, actually, when it's -5 plus 3, I get a -3. So a negative times a negative times a negative isn't positive. It's going to be a negative. And I can see on my graph here that that's true, that I have negative values. So my next interval is going to be from -2 to 0. So I'm just going to pick f of -1. So I'm going to get that this is equal to -1 times -3 times 1. Again, it's a negative times a negative. So this is going to be positive times a positive is going to stay 3. Again, not super concerned with the value, but I want to know that on that interval, I'm going to get positive values. So from -2 to 0, I can see I have positive values. So 0 to 2, I'm just going to pick 1. So f of 1 is going to be equal to 1 times -1 times 3. Again, a positive times a negative times a positive is going to be a negative value. In fact, it's -3 I'm not super concerned with, but this interval it's negative, so I can see that that's below the axis there. And for my final interval for 2 to infinity, let's just pick 10. So f of 10 is equal to 10 times 8 times 12. Again, all positive net numbers. All I'm concerned with is that this is positive. So I'm going to have positive here, and I can see on my graph that I have positive values. So looking back to the inequality, I wanted to know when f of x is greater than or equal to 0. So it is inclusive. So when did I get positive values? I got positive values here, and I got positive values here. So that gives me, and it's inclusive. So on the interval from -2 to 0, inclusive, and from 2 to infinity, inclusive here, can never reach infinity, so it's an open bracket there. So this is my solution for the inequality of that polynomial there. Notice how your solution should match up with your graph. Again, from -2 to 0, it's positive, and then from 2 to infinity, it's positive as well. All right, again, for number 3, make sure we get things equal to 0 first. So then I'm going to have x plus 2 squared minus 25 is less than 0. Let this be equal to our function f of x and find its zeros. For this one, I'm going to go ahead and we could solve it by distributing and factoring, but I'm going to go ahead and solve it by the square root method. So I'm going to get 0 is equal to x plus 2 squared minus 25. Add 25 to both sides. And I'm choosing square root method because it's nice, because I know I got a perfect square here. So when I square root both sides, I'm going to get plus and minus 5 is equal to x plus 2. Remembering I'm going to have two solutions here. I should expect that with a quadratic having two roots. Fundamental theorem of algebra reminds us of that. And from here, I got to break it up. So I got x plus 2 is equal to 5. I have x plus 2 is equal to -5. So I solve this out. This is going to give rise to x equals -3, and this one's going to give rise to x, oh, that's a +3, and x equals -7. So then again, I'm going to break it up into my intervals here. So my two zeros are -7, that's my smallest one, and then 3 is my largest one. So let's go ahead and pick -10. So if I do f of -10, just to be fitting into this interval, and then I'm going to get -10 plus 2 is -8 squared is going to be 64 minus 25. Not too concerned of the value. I know that it's positive. So I'm going to be positive in that interval. My next interval is from -7 to 3. 0 is a nice one to pick in there. So I'm going to do 0. 0 plus 2 squared is 2 squared, which is 4 minus 25. Well, that's -21, but what I'm concerned about is the negative here. So I know that on this interval, it's negative there. And then for my last interval, 3 and above, let's just do 4. So f of 4 is equal to 4 plus 2 is going to be 6. 6 squared is 36 minus 25 is 11, but all I care about is that this value is positive. So again, I can see how this matches up on my graph, that I'm positive from 3 and above, and that I'm negative from 3 to -7, and then again from -7 and above to -infinity, I'm going to be positive. So answering this question, when is it less than 25, non-inclusive, so it's negative in this interval. So my solution, write it down here, non-inclusive, open brackets, from -7 to 3. So number 4 here, we have a rational function. So I want to go ahead, it's still same rule, set equal to 0 one side. So I'm going to subtract 3 to both sides. So I get 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. So I want to try and simplify this and define this as my function. So f of x is equal to 2x minus 7 over x minus 5. So to simplify these, I want to get a common denominator. So I'm going to multiply this by x minus 5 over x minus 5, a convenient choice for 1, right? So as we distribute this -3 through, I get 2x minus 7 minus 3x plus 15 in my numerator. My denominator is common, so I can combine them. It's x minus 5. As I collect my like terms here, I get -x plus 8 over x minus 5. So when we set up our intervals for rationals, we don't only want to include the zeros, but we also want to include anywhere where our domain, we have issues with our domain or we get our vertical asymptotes. So on this one, so in other words, we got to figure out where it's 0 in the numerator and in the denominator. So in the denominator, I'm going to get a 0 here at 8, numerator, and in my denominator, I get a 0 here at 5. Okay, so again, I want to test values within those intervals. So this is 5 to -infinity, so 0 could work here. So I'm going to do f of 0. So I'm going to get -0 plus 8 is just going to be 8 over 8 minus 5 is going to be 3. So that is positive. Actually, we get 8 over -5. So that's going to be -8/5. So I don't care that it's 8/5. I just care that it's negative here. So we're negative in this interval. So my next interval is 5 to 8. Let's just pick something nicely in between. So let's pick 6. So f of 6 is going to be -6 plus 8 is going to be 2 over 6 minus 5 is 1. So it's going to be positive. So it's positive in that interval. And then again, I see that it's things greater than 8. So I'm going to do f of, let's say, 10. So I get -2 over 5. Well, it's negative. So on that interval, it's negative. So this here is our graph of this function. So I want to know when it's less than 3. So if I think, here's my, when y equals 3. So when is it less than 3? Well, I can see it's on the interval here. And that's represented here. So from -infinity to 5, and it is a closed bracket because I am inclusive, and at negative infinity is always open. Okay, then it's positive from 5 to 8, so I'm not going to include that because I want things less than 3. And then I also want the interval here that I can see was negative or less than 3 on the interval from 8 inclusive to infinity, my open bracket. So that is the solution to this inequality, all those values in those intervals. Last example here. All right, so again, get 0 to one side, so I'm going to subtract 4. So I got 3x minus 5 over x minus 5 minus 4. That's going to equal my function here. And then I want to simplify this. So I get 3x minus 5 minus 4 times x minus 5 over the common denominator, x minus 5. Collect my like terms. I'm going to get negative x minus 10 over x minus 5. So again, I want to set up my interval and include the values where we have issues with our domain and where we get zeros. So the numerator, I'm going to get a 0 at, gotta check my, here we get negative 4 times negative 5, and that's going to be plus 20. Minus 5 is going to change this to actually get negative x, and I'm going to be plus 15. So my x's are going to be at 15 and at 5. So that's where the numerator would be 0. That's where the denominator would be 0. So I need to check these intervals. So these intervals here are going to be, well, let's go ahead and check 0 here for this interval. So f of 0 is equal to 15 over negative 5. So that's negative 3. But again, all I care is that this function is going to be negative on that interval. So f to 15, let's go ahead and pick f of 10. So that's going to be equal to 5 over 5. That's 1, but what I care about is that it's positive on that interval. And the last one, 15, let's just do f of 20, something in the interval from 15 to infinity. So I chose 20, so I get negative 20 plus 15, so that's negative 5 over 15. So that's going to be negative 1/3, but what I care most about is that it's negative. So as I'm answering this question, when is this greater than 4? Okay, non-inclusive, so I'm going to have open brackets. So I want to know when this function is greater than, so that's when it's positive. So I'm going to have on the interval from 5 to 15, open brackets at each. And I can see on my graph, when was it less than 4? Well, it's or when is it greater than 4? It's less than 4 here, so that's not part of my solution. And I can see from 5 to 15, I'm going to be greater than 4. So that was part of my solution. And then here, again, it drops down, and I'm going to be less than 4. So that's not part of my solution. All right, that's it for notes tonight. Go ahead and highlight any questions you have and bring them to class tomorrow.